So 7.1 was talking about some basic probability. We did some complex probability, looking at the addition and multiplication rule. Okay, 7.2 is going to be the binomial distribution. This is going to be a situation where you're going to be trying to find how many times something's going to happen in a set number of groups. Binomial distribution kind of goes back to the rugby example we did before. So let's take a look at that now. Okay, 9 out of 11 men love rugby. And this question is, what is the chance that you pick 2 men, all of the men will love rugby? Now, remember, that 9 out of 11, that's the parameter. So that's going to be an independent, it's not going to change. Okay, it's always going to say 9 out of 11. Now, if we were to do this problem, pick 2 men and all the men love rugby, you could say 9 out of 11, 9 out of 11, and multiply across. Okay, I'm not going to do up the work right now, but that's how we would set up the problem. Now, what if I asked you, what is the chance that if you pick 5 men, exactly 2 love rugby? Okay, here was 2 for 2. Here we're going 2 out of 5. So you would think, okay, we need 2 people who love it, 9 out of 11, 9 out of 11, and the 3 other people don't love it, 2 out of 11, 2 out of 11, and 2 out of 11. That 2 out of 11 is a complement. If 9 out of 11 men love it, that means 2 out of 11 don't love it. And you multiply right across. Okay, now my question to you is, if I'm asking 5 people if they love rugby, am I guaranteed that the first 2 are going to be the ones that love it and the next 3 not? No. I mean, it could end up being 2 out of 11, 2 out of 11, 2 out of 11, and then 9 out of 11, 9 out of 11. So this time the last 2 people love the rugby. Okay? There's another situation. Another way it could happen was 9 out of 11, 2 out of 11, 2 out of 11, 2 out of 11, and then 9 out of 11. So the first person loves it, the last person loves it, the 3 in the middle don't love it. All these situations need to be taken into account. And this isn't it. We could keep going on, writing all the ways those 2 people love rugby. Where do they fall in the 5 people that we're asking? Okay? So we have to keep writing out more and more situations and put all those together. So this is what the binomial situation is going to do, the binomial distribution. If we have a set number of trials that we're going to run for a situation, we want to know out of that set number, how many times is our success going to happen? In this case, our success was 2 people loving rugby. That's what the binomial is going to do for us. Okay, so let's take a look at that. Okay, the rules for it to be a binomial distribution. Okay, you must have a certain number of trials. That's what we had in that last question. 5. We were going to ask 5 people if they love rugby. We were set on 5, so that's our 5. That's going to be our total number of trials. You can only focus on 2 outcomes. So our outcomes for that was either loving rugby or not loving rugby. And must be independent events, meaning that percentage, in our case 9 out of 11, was going to be set. Okay? It didn't say, okay, if you get 1 person that loves rugby, now it's going to be 8 out of 10. That 9 out of 11 was a set probability for our situation so we could move forward. These are the 3 rules that you're going to need to follow for the binomial distribution. Okay, so we're going to look at things like that, and we're going to look at 2 ways of solving it. This first video is going to deal with the formula. So there we have NCR times P to the R power times Q to the N minus R power. Now, a lot of variables up here that we're going to have to identify. This C here, that represents combination. That's a combination that we really haven't talked about yet. We talk about it in the next section, 7.3. But that's taking care of all those ways we can move the pieces around, how we were doing that, moving the 9 out of 11 or the first 2, the last 2, the first and last. All those movements, that's what our combination is going to do for us. Now the rest of the variables, we have N being our total number of trials, R being the number of successes, so N would have been our 5 men, R would have been our 2 people that love rugby, P is going to be a probability of success, and Q is going to be a probability of failure. Okay, so those are the 2 probabilities, the 9 out of 11 and the 2 out of 11. You have to remember that the P and Q are going to be complements. Okay, so they have to add up to our 100%. They have to add up to a whole. Okay? Make sure you're looking at this formula. I always think it's good to separate into three. We have our combination, we have our p to the r power, and think of the q to the n minus r power. Okay? So there's our formula that we're going to look at. So let's look at some examples. Okay? Here we're looking at 23% chance. Okay? 23% of the light bulbs in a shipment are broken for each shipment. If a shipment has 50 light bulbs, what is the chance that exactly 21 are broken? Well, I'll put out the word exactly here. Okay, we're looking at exactly 21. Now, I know a broken light bulb does not sound like a success. It's what we're looking for. So in this case, we are not counting a success. Okay, putting the formula back up here. Now let's write down some of our values. For our n, total number of trials, we have 50. Our r, that's the number of successes we're looking for. We're looking for exactly 21. And our P and our Q. Our P is a 0.23 because that's the chance of a broken light bulb. And our Q is going to be the complement of that. So in this case, 0.77. Remember, they have to add up to 100%. I have them in decimal form, so they add up to 1, 0.23, 0.77. Now, if I'm going to write all this out for us, I might use parentheses to separate my three groups. Okay? Now, NCR, I'm going to write as 50, C, 21. So there's our combination. I'll show you how to plug that in a second. For our P to the R power, 0.23 to the 21st power. And then we have 0.77. I'm going to do the N minus R power subtraction in my head. It's easier, it's one less parenthesis you would need. So we have 50 minus 21 is 29. And close the parentheses. You can plug this in exactly how it looks here. With the parentheses, it's keeping the order of operations. Nothing should get mixed around. I think it'd just be easier to plug it in just the way it looks. Not less rounding mistakes could happen. Now to get that combination, okay, if you have one of our graphing calculators, you're going to want to go to Math. Okay. At the end, you should have a menu PRB. That stands for our probability. Okay. And in that menu, you should see NCR. That's a menu we're going to go to a good amount when we get to 7.3, the counting. But right now, all you need is the NCR. Okay, for that. And you're going to plug it in as 50C21. Okay. 0.23 to the 21st power, 0.77 to the 29th power, and you should get, again, I'm going to ask you for percentage form to the 3 decimal places, and it's a pretty small percentage, 0.136%. So there's our situation there, and it is an ugly formula. Take your time plugging in, make sure you're getting that percentage. Okay, make sure you have all the numbers in the correct spot. Make sure you have decimal points. Okay, so a lot of things have to go into this for that to work out. Let's look at one more example. Okay, so we have our same percentage, 23% of light bulbs in a shipment are broken for each shipment. If a shipment has 200 light bulbs, what is the chance that exactly 40 are broke? Okay, so now again, let's go right to our N, R, P, and Q. Okay, this time our total is 200. A success, we're looking for 40 broken light bulbs, and our P or Q are staying the same, 0.23, 0.77. Okay, so take a second, you might want to pause this. Try and write it out yourself to see if it matches what I have. Okay, so if I write this out, okay, so I have 200, the combination, 200 combination 40, 0.23 to the 40th power, 0.77 to the 1/60th power. Okay, so I'll take a second, plug it in, and you should end up with a little bigger probability. I have 4 0.163%. Okay, so hopefully you got that percentage. Again, turn to a percentage, rounded to 3 decimal places. Okay, and the other thing I'm going to point out here, the word exactly 40. Okay, the next videos I'll show you some formula problem examples that are not exactly a single value for success. It might give you a range of values, so I'm going to show you how to deal with those. Okay.